Alright, here we go. The third video in our series. This is from section 1.4 in your book, talking about functions. I call it Introduction to Functions. Hopefully it's a slight review of function. Four things we're going to talk about. What is a function? How do we test if something is a function algebraically? Our favorite thing to do. How do we evaluate a function? And what is the domain of a function? How do we determine the domain algebraically? Alright. Let's take a look at this first part. Here's what your book has for our lovely definition of set notation. It's a little wordy. A function f from a set A to a set B is a relation that assigns each element in X, the set A exactly one element Y in the set B. The set A is the domain or the set of inputs of the function f, and the set B contains the range or the outputs. It's really wordy and really complicated, but there's two important things here. Basically, a function describes a relationship between two sets, and then the other important thing that really separates it from other relationships is that for every input we have one output, or at most one output. We can have cases where there isn't one, but we can never have an input with two different outputs. And so if we look at the relationship here, we have x squared. So for every input I have, my input is 3, my output will be 9, and so on. So this is just one way of looking at a set. Down here at the bottom, though, we have an issue. We have the input of 5, and we have 3 different outputs. So this can't be a set, or excuse me, can't be a function. It's a relationship between two sets, but it's not an example of a function because we have 3 outputs for one input. Alright. So the question is, if I was given an equation, how do I know if it's a function? And the simplest thing to do is we solve for the dependent variable. And so in this case, the dependent is y, that's my output. My input, or my independent variable is x. And so I'm going to solve for y and try to get it by itself. If I can do this, then I have a function. So if I do this here, I end up with y equals 1 minus x squared. I've easily isolated this variable, and I know that I have a function. However, if I try to do something similar over here, I'll end up with y squared equals x plus 1. If I take the square root of both sides, I now have this issue, y equals plus or minus the root of x plus 1. And this here lets me know that I no longer have a function. I now have 2 possible outputs for the same input. Right? If I plug in 2 for x, I would have y equals the square root of 3, and I would also have y equals the negative square root of 3. So I have an issue here. I have 2 outputs for only one input, so I don't have a function. So anytime we come up with this plus or minus, we know we no longer are working with a function. Here's a couple examples. We got 2 steps here. Isolate the variable, isolate y, and then after we've isolated y, we have to try to see if we have one output. And really the one issue you have to worry about is the case where we get something with the plus or minus. So go ahead and take a look at those. Alright, some notation stuff. If we look here, this is an example of some function notation. This is the function f, my input or my independent variable x, and then this will be my output here. Alright, so I'm inputting an x, I get something out here, and in this case, my output is defined by x squared. So if I want to use this function, I want to find f of negative 2. Negative 2 is my input, and I input it for every x value, so I have negative 2 squared. My output would be positive 4. If I want to evaluate for negative 1, f of negative 1, and I plug it in everywhere for my x value, my output will be positive 1. And likewise, we can do this for f of 8, we would say, which would be 8 squared, or 64. Alright, moving on. Couple examples. This is your function. Its v is a function of r. This would help if this was here. So you're going to take and you're going to evaluate for 3. you're going to evaluate the function at 3/2, and you're going to also evaluate at 2r and simplify. Alright, we also talk about domain of a function. The domain of a function is all possible input values. Alright, normally we don't have too many issues defining the domain, but there are a couple cases where my domain is limited. In this case, dividing by 0 causes an issue with my domain. So my domain here would be all real numbers, except for I have this issue with putting something in here. So if I look at this, 2 and -2 cause issues in my function because I'll be dividing by 0. So my domain is going to contain all real numbers except for 2 and -2. There's a couple ways to write this, and we'll talk more about that in class. Another one that we can't have here is the even root, so the second root, right, square root of a negative number. So if I put anything in here that is smaller than the number 4, I'm going to end up with a negative square root. So my domain is going to be all numbers greater than 4. And we could use interval notation to show our domain here. So it's going from 4 to infinity, and we probably want to make that a bracket because I can't include 4. I would have 4 minus 4 square root of 0. So my interval, or my domain, would be from 4 to infinity. Alright, a couple of practice problems here. Look for both of these issues. Don't worry about, this should be a divided sign, excuse me. Don't worry too much about the notation, but at least get an idea of what can and cannot be in the domain here. And we'll discuss formally how to write that in class. And apparently that is it. And good luck.